Hi, we're just going to go over a summary of the factoring methods that we've looked at so far. So we've looked at 4 methods: common factor, factoring by grouping, sum and product, and difference of squares. It's important to know when to use these, so when you see a question, you know which one you should try first and which one you should try next. The answer for which one you should try first every time is the common factor. Common factor, always want to take that out, because if you don't take that out, you're often working with bigger numbers than you need to. Sometimes you can't actually apply the other methods, so always try the common factor first. The other 3 somewhat depend on how many terms you have. So if you have a lot of terms, 4 or more, you want to try factoring by grouping. If you have 3 terms, it's often going to be sum and product, but they have to be in a particular pattern. So what's called quadratic form. So you have something times your variable squared plus something times your variable plus something. So those somethings will all be filled in with numbers. And the last one is if you only have 2 terms, you're often looking at difference of squares. But again, it has to follow a certain pattern. You need 2 perfect squares, one subtracted from the other. Now, particularly in the 2 squares, I would note that there are some other methods such as sum and difference of cubes, but we're not covering those at this point. So when we're looking at these, we've got some examples. So our first example, 6x squared y plus 18xy. You might think, oh, 2 terms. Let's try sum and difference of, let's try difference of squares. But it's not a difference, it's an addition. And we don't have perfect squares. Also, we haven't done the thing we're supposed to always try first, factoring out a common factor. So if we look at this, common factors, remember, can be numerical or they can be literal. In other words, you can take out numbers or letters. So we have 6 that we can take out of both of these, we have x we can take out of both of these, and we have y we can take out of both of these. So when we do that, we end up with 6xy, x plus y in brackets. So remember how we get that. We take the 6 out of 6, we're left with 1, which we don't necessarily have to show. X squared divided by x leaves us with x. Y divided by y cancels out. Likewise on the other one, 18 divided by 6 gives us 3. X's cancel. Y squared over y just gives us y. Always we can check these by multiplying back in. So the next one, we've got 4 more terms. Remember, when we're factoring by grouping, we're still using common factor, but we're taking them in pairs. So we're going to try factoring by the first pair and the second pair. And remember, if that doesn't work, you can always rearrange things, because sometimes it does make a difference to rearrange. So out of the first 2, we can take out 2x. Out of the second 2, we can take out 5. So when we do that, in both cases, we end up with 3y plus t. Right? We take 5 out of the second one. We also end up with 3y plus t. If we didn't end up with this term being the same, that's a big hint that this factoring by grouping was either done wrong or isn't helping. So we're looking for that repeat factor. Then we can take that out as a common factor and group our fronts together as our other factor. Again, check this by distributing. So 2x times 3y, 2x times t, 5 times 3y, 5 times t. We do come back to our original expression. So this next one, we are following that quadratic form. So we have something x squared, in this case 4x squared, plus something x, 8x, plus, again, our last constant term, 3 in this case. So when we're doing that, we want to use the sum and product method. Remember, the sum is always our middle term, the coefficient of our middle term, that is, and the product is always our first coefficient times our last term. So in this case, we're getting a sum of 8 and a product of 12. So we want two numbers that add up to give us this middle term, but multiply to give us 12. So remember, think about those factors of 12. Could be 1 and 12, 2 and 6, 3 and 4 in some combination. And the only one that works to give us the sum is going to be 2 and 6, right? Because that's going to add up to 8. So we take that 2 and 6 and we split it into that. Split the middle term into that. And then we can factor by grouping again. So out of these first two, we can take out 2x. Out of the last two, it appears that we have no common factors, but remember, you can always take out 1 or minus 1. And always for that second pair, remember to take out a sign along with your factor. So in this case, we can take out plus 1. Just like we did with our 3y plus t, we're going to take our 2x plus 3 and make it one factor. Our other factor will be the 2x plus 1. Also remember, the order doesn't matter with our factors, so whether I write 2x plus 3 times 2x plus 1 or vice versa, we still have the same result. Last example here, difference of squares, but my first one's not a perfect square, right? 6 isn't a perfect square. 150 is not a perfect square. So how can this be my example under difference of squares? Well, I put this one in to remind you, always try the common factor first. So we can take out a common factor here. Specifically, we can take out 6, and then we can see we have x squared minus 25. Once we have that, yes, we do have perfect squares, because x squared is the perfect square of x. 25 is the perfect square of 5. Remember, with difference of squares, we always take the square root of that first one, and it becomes our first term in both factors. We take the square root of the second one, it becomes our second term in both factors. And so the only thing we got to remember there besides that is subtraction on one, addition on the other, and it doesn't matter which order as long as we have one of each. So that's our summary of factoring methods.